Hello, everyone. So today I will be discussing about Module 8, the length of the confidence interval and appropriate sample size. So this is the module. And these are the learning competencies which we hope to achieve at the end of this module. So you are going to learn how to identify the length of a confidence interval and compute for the length of a confidence interval, and then the appropriate sample size using this length of interval, and also other exercises involving sample size determination. So it's going to be ihahati na ko rin into two parts so that dili kayo ataas ang video. So let's start with the first two. First, let's cover the first na Melks first. So, sige. So let's start with what I know. We are asked to find the length of the following confidence interval. But first, if mo ka-ask, unsa ganin na siyang confidence interval? Di ba? Nakuha man ninyo. I'm pretty sure you already covered this in yung statistics at nga subject back in junior high school. Pero, mahatan ako a quick recap on what a confidence interval is. So let's look at this this graph. So this is the normal distribution yung curve, di ba? So confidence interval is basically a fancy kanang way of saying na kuan, or we can just pwede natin na mubasa sa kanang sa description dito, mangita tag spoilers. So a confidence interval in statistics, it refers to the probability that a population parameter will fall between a set of values. So ang kanang kuan, mag-compute kita mo pangutanan kaunsa ng confidence interval, so between this value kintahay and this value. So this length in between is the length of the confidence interval. So, or kanang siya ba, range siya sa imuhang kanang kuan, sa imong values nga maigo ani nga area under this curve. So, wala na kanang pasabot niya. Now, from the kanang first nga kanang what I know, these are kanang recollection exercises for you. So, mara na siya ang inyong kanang and we're not going to tackle that karon, but we're going to start directly sa kuan kay nga if there are any concepts na kailangan niyo review, it's this one. So ano mo mag-review dapat. So we're going to skip that part. So kani siya, let's talk about this. Let's talk about the kanang kuan, the confidence. Sorry about that. So from this here, confidence intervals measure the degree of certainty or uncertainty. So matong giingon ako ganiha nga unsa man ka certain nga mo fall ang usa ka value between kintahay ani nga limit and ani nga limit. So this of course is lower limit would be the lower confidence limit, and this higher one would be the upper confidence nga limit. Example lang gusto itong gihatag ganiha. So they could take up any number of probability limits, with the most with usually when it comes to quantitative studies kay ang in common jud is the 95% or the 99% confidence level. So it basically is a way to measure kanang kuan ba murag kanang kuan usa na siya sa kanang, it's a way of measuring the degree of uncertainty. Murag kanang kung unsa siya ka certain nga ang values mo fall under this area right here. So there is also this another term nga kung kanang introduce niyo. This is called the length of the confidence interval. So it's right here. I'm just going to highlight it for you. So it refers to the absolute difference, basically the distance sa lower confidence limit and the upper confidence limit. So this length right here. So how is this length computed? So si LC ang iyahang kanang lower nga limit, ang basically ang buhaton nato is the pangitaon ang difference between the upper confidence limit and the lower confidence limit. Okay. So how will that look like in Tahay if we were given this one? So, kani, examples lang ni siya. If you are given this one, so the solution is there now. So, di na ko kailangan mo suwat. So, basically, si kanang kuan, si LCL, kintahay, is nasa 0.36. Nya kani siya si, joke, back. 0.275, and si upper confidence limit is nasa 0.36. So, LCL would be equal to the absolute value of the difference between this two, 0.275, which would be length, din siya, length of the confidence interval, which should be equal to 0.085. That's so therefore the length of the confidence interval will be equal to 0.085. Next, same magyapon na siya, daghan kayo siya examples, very generous kayo examples ang kuan. So I'm pretty sure ang kaninga examples are very easy peasy for you, okay? So we're going to look at unsay relationship between kanang kuan kanina sa let's go back to this formula. Unsay relationship sa confidence interval and the if given ka og population mean pwede known nga variance. So importante ni siya nga kayo nga formula kaning kuan dire kaning describe here kani. Also kanina po another thing I don't understand sad nganong I don't understand sad nganong kanang kuan nganong ingani ni siya sa what you call this ingani ni siya nga module but kani siya is actually plus ni siya. So this is basically the formula for your lower confidence limit and your formula sa imong upper confidence limit. Clear all drawings. Okay. So kantahay natin gani. So ang basically kanang tong deriving from the formula sa imong sa kuha sa kanang length of the confidence interval, it would just be adding the distance sa ani nga portion and ani nga portion, because ideally ang kaning imong upper o kanang upper confidence limit o imong lower confidence limit kay pareha ra untag value and i-add na siya, so mo ni siya ang imong length gamit sa katong formulas previously. Next would be let's try to answer this example kintahay. We're going to let's take this formula right here, and then right there. So this formula ato ni siyang gamiton in solving for example 3. Di natin siya butang dito. Natin siya here. So we have step by step na siya. We have the given. So we have the given. Ako sa nang clear frame Clear frame. May nawapod. Okay, never mind. Okay. So we're being given the following. The given is the population standard deviation 0.3 and the sample size, which is 70, and also the confidence level kung asa ito magbase, which would be 95%. So one is a given. So ang atong pangitaon una is ano to siya ang z value. Ang z value basically not at A, okay? Not at A, but at alpha half. Ngano man, 1/2. Ngano man. So, 'di ba we talked earlier kanang alpha is basically just another way of saying the kanang confidence interval or the confidence level, rather, ang confidence level. Pero lahi ang implication sa kanang sa duha because like for example, an alpha of kanang an alpha of A nga 1/2, kintahay ang alpha nimo kay 95%. It means nga kuan ang usa ka alpha nimo nga kay naa diri sa lower limit niya napud kay upper limit. You're assuming that all your values fall between these two nga kanakan, these two limits, which is mana tong assumptions kaniha for for what do you call this for sa kanang which is mana tong tong gikan buhat niya for normal nga distribution. Pero sometimes anong po ibang assumption sila nga mag one-sided lang. So it means nga kanang kuan ang instead of kanang kuan like for example ang 95% diba at a confidence level of 95 ang kanang kuan ang remaining na portion ani would be kani nga aning areas would be equal to 5%. So this area right here would be equal to 2.5% and 2.5% para mahimo ni siyang 100%. Pero sometimes ang kanang kuan there would be some nga kanang people especially ug mag one-tailed test sila nga ang 95% would be just in one side area. So na si alpha, mo si alpha katong sa may alpha 2 kanang divided by 2, and this whole chunk, this large chunk right here would be 5%. So with this formula we are assuming the former. So kaning i-erase I'm making a lot of squiggles. So first, atong buhaton nato ay pangitaon nato si z alpha divided by 2. So this is how you do it. So see 1 minus, and in order to look for alpha, find A in equation 1. So this is how you find A. Because your A is just basically the reciprocal, and not really the reciprocal, pero mo na ang imuhang inverse sa imuhang confidence level, 95%. And so on and so on. You can just follow this kanang step by step right here, and it would lead us to an alpha over 2 of 0.025. To 0.025. Kani siya if panaman imong buhaton depende na sa imong table. Mao man ang gigamit na table, pero ako kay ganahan man ko nga kanang mogamit aning nga table. I'm gonna show you guys. It's right here somewhere. Diba unsa to siya? 0.025, right? So kani siyang ang right kanang be careful ba gyud ka sa kanang when it comes to having z tables or kanang kuan kay because ang pasabot with ani right tail nga probabilities katong nasa kanang module kay ang iyang gi-report niya kay kung unsay naa diri. Pero ug naa say annotation nga right tail nga probabilities like this one, ang iyang pasabot niya is that the person is reporting the right side sa kanang kuan the right side sa area, which is this one. So if ang pasabot nako kay ani kay like kanang kay compute man nato is this one, the kanang kuan the 0.025. So this one would be 0.025. I would want to look for the value nga 0.025. So where is it? It would fall here, diba? Same maghapon, 1.96. So just like in the module, except that ang iyang pamaagi is different. Ang pagpamangita niya. So the z at alpha over 2 would be 1.96. So we substitute this value back sa atong first na to nga equation. Butang na to ni here. Or kanang tani. So let's say this is equation 1 and this is equation 2. Okay. So ato ni substitute kintahay diri sa ani nga equation. Diba, given man eh. So we have this one. We also have this one. And right now, and after solving for the z at this nga alpha, nakakuha na sila ang value. So all we need to do is to substitute it to the first nga formula in order to look for the lower confidence limit. So the LCL would be equal to substituting this unsa man siya. Okay. Wait, no, it's looking for the, I'm sorry. It's looking for the length, di. So it's not looking for the lower confidence limit. So sorry, let's erase this. It's not looking for this, it's looking for the formula number 3, which would be this one. The 2z a over 2 9. So length. So this would be 1.96 multiplied by 0.3 over the square root of 70. This, kung ato ni siya compute, would be equal to, okay, joke, would be equal to 0.1406. So this is so atong ito na conclude na to, the length okay, see. This is the reason, also another teachable moment. This is the reason why kailangan jud ang format na kanang kailangan ta makahibaw unsay ask or unsay gipangita sa problem. So okay, my mistake. Wa ko nagsuwat unsay ask. Ang ask di ani is the length of the confidence interval of PCL. Okay. So the length of the confidence interval would be equal to 0.1406. So always make sure to know what you are looking for, kay sometimes we get caught up sa ato ang mga solutions and then we forget nga layo naman dito sa point sa ato ang gi-solvan. Now we move on sa kuan. Another version if the in looking for the confidence interval of the population mean. So this would be used if ang n it would be less than 30 or if sample size or siya. So same again if you notice kaning formula and is really just similar to this one. Itong sa first one nga atong ipakita. So, see? Ini-zoom. And also, just like so, nakalimot po kung kanang kuan, kay kani siya plus ni siya. So, we have the minus here and we have the plus. And same as ang formulas when it comes to kanang kuan, looking for the length of the confidence interval. Except, of course, ang iyahang kanang kuan nga, instead of z, t, ang iyahang gigamit, ang p-value. So let's kind of clear all drawings like that. So let's try to kanang kuan. You can just solve it like so similarly sa katong kuan, except of course this time since t naman siya t table sa inyong mohang gamiton, can follow the step-by-step formula, and that's how you get the kanang kuan, the length of the confidence interval. Now, we will try to move on daw sa sample size. Let's look for a kuan. Let's look for a share screen. Let's look for a kanang kuan. Let's go to the next page now. Okay.